In our first section, we are going to be exploring exponents. And I know a lot of you already know this, and I love to start with things I think you already know. I think you already know what exponents represent. So I have down here a quick example of what an exponent is. 2 to the third power. And this exponent represents how many groups of multiplication there are. There are 3 groups of 2 multiplying each other. So when you see 2 to the third, it doesn't mean 2 times 3. It means 2 times 2 times 2. And so you do this from left to right. You do 2 times 2, which is 4. And then you take that 4 and you multiply it by 2, and you get that it is 8. That is what exponents are. Now, I want to jump into the thing that some of you kind of got a little confused with maybe last year. So let's write down negative exponents. This is my second bullet point. Negative exponents represent the opposite of multiplication. And so I'll put in parentheses division. Let me zoom in a little bit more on that so you can see a little bit better. Negative exponents represent the opposite of multiplication. So I'm not sure. I know that you have seen this before sometime over in junior high school, but I don't know if anybody has ever explained it to you this way, because I saw this on a video over before Christmas break when I was thinking about how I was going to teach this. Negative exponents represent the opposite of multiplication. When I said 2 to the third power, that meant I had 3 groups of 2 multiplying each other. When you see 2 to the negative 3, what that negative 3 means is instead of having 3 groups of 2 multiplying each other, we are going to have 3 groups of 2 dividing each other. Now, when you think of dividing by 2, hang on, Ray. When you think of dividing by 2, what I want you to think of is as a fraction. When I divide by 2, I half it. I take a half of something. So if I have 2 to the negative 3, it means I have 3 groups of dividing by 2 that are multiplying each other. I'm dividing by 2 here, and dividing by 2 there, and dividing by 2 there. Instead of us multiplying by groups of 2, I'm now doing dividing by groups of 2. So when you look at a negative exponent, 2 to the negative 3, it means you have 3 of those groups, but instead of it being in the numerator, it is in the denominator, which means it's the same thing as 1 over 2 to the third, which means it's the same thing as 1 over 8. If that makes sense to you, put your thumb up for me. If that is kind of confusing to you, you can go midway, or if it's something that doesn't make sense to you, put your thumb down, please. Okay. I see some sideways, I see some up, and so we're maybe 50-50. Thank you very much. I'm going to go more into depth with this in a little bit, but let's just write that down for now. Next thing. Next bullet point. Anything to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So I have this example just to remind you a couple things. This is my example here. I have 3x to the 0 power. And I wrote this example down because I want you to pay attention to the small things. The small things are where students make mistakes, okay? So when I look at this, the x is to the 0 power, but the 0 power does not go to that 3. That 0 only is for the x. If I look at this 3, there is an exponent that is there. Like, how many groups of 3 do I have? I have 1. There is an invisible 1 right there. So I actually have my fourth and last bullet point says this: invisible exponents are equal to 1. Everywhere in math, when you don't see a number, it's an invisible 1. There's only one place in math that's an invisible 2. I'll let Ray think about that. There's everywhere in math, it's if you don't see a number, it's an invisible 1. It's only one other place where I know that there's an invisible and it's not an invisible 1. So for example, this 3 is 3 to the first power, and I have x to the 0 power. This simplifies. Anything to the power of 0 is equal to 1. X to the 0. What is x to the 0? 1. And what are we doing with the 3? The 3 is multiplying that x to the 0. 3 is multiplying the 1. And what is 3 times 1? Just because I have this rule, anything to the power of 0 is equal to 1, does not mean that your answers will always equal 1. Sometimes they might be 3. Sometimes they might be negative 3. Sometimes they might be negative 1. It just depends on how the problem is written. Okay. Let's start with looking at something that looks like number 7. So I'm going to put number 7 here in a box. What that's going to represent to you is that number 7 on your worksheet. This matches number 7 on your worksheet, so you have an example of what you are going to be asked to do. Number 7 looks like this: negative 11 to the 0 power. Let me lower that down just a little bit. This one's tricky. This one, the first time I did it, I almost got it wrong. What I want to remind you is there's order of operations here. Okay? When you look at this, is the negative in parentheses? Are there parentheses here? No. So what that means is, if you see a problem like this, that means that the 11 is to the 0 power and the negative is not to that power. That this is like a negative 1 times 11 to the 0 power. So that's how I'm going to write it. I'm going to write negative 1 times 11 to the 0 power. I want you to think of it like that. Or if that doesn't make sense to you, think of it in terms of, please excuse my dear Aunt Sally. If I have please excuse my dear Aunt Sally, I'm going to just write that off to the side. I have to do exponents before I do any subtraction or multiplication. I have to do this before I do that, because order of operations says do the exponents first, then do any addition or subtraction or multiplication. So what is 11 to the 0 power? That's 1. That's 1. And then we are multiplying it by the negative. Our final answer is negative 1 for number 7. I'm just curious, how many of you knew it was negative 1? Raise your hand if you got that right before I even explained it. Okay, that's kind of what I was thinking. That's 25% of you. You're good? Okay. Let's do number 5. Number 5, negative 5 to the negative 2 power. Negative, parenthesis, 5, parenthesis to the negative 2 power. I want you to put down what you think this simplifies to. If you get it wrong, you get to cross it off and you get to write down the right answer. And then what I want you to do, after you write down what you think it is, I want you to look at the person you're sitting next to and see if you have the same answer. Go ahead and try it right now. What do you think it is? Then look at your neighbor and compare, and you can discuss who you think is right. Oh, so you're still thinking about the question I asked you. Okay. No. No, something simple, something you've seen before. And I won't tell it to you right away, just so that you have something there that you can ponder. How many of you are still working? 1. Last try. Go ahead and put your final answers. Okay. Here's what I would get. You get to see if you're right or if you're wrong. This is what you get. This is outside the parentheses. I have to do exponents first. Since I have 5 to the negative 2, instead of groups of 5 times 5, I have groups of division. So I'm going to put this as 1 over 5 times 1 over 5. That's what that means to me. There's 2 groups of 1 over 5 times 1 over 5. And I'll write down a shortcut for that in just a second. But there's still this negative that's there in front of it. And so what I have is this like negative invisible 1 times 1/5 times 1/5 gives me negative 1 over 25. The correct answer, the final answer you should have is negative 1 over 25. How many of you have that as your answer? Raise your hand if you got it right. Ooh, that's not very many. That's only 5 of you. Okay. I'm glad I picked that one so that you know how to do it, hopefully, from now on. Something I want you to think of, this is a shortcut. I'm going to put down here. Negative exponents move to the opposite side, top to bottom or bottom to top. Oh, you can't see that. Let's scoot it over a little bit. Negative exponents move to the opposite side. The top goes to the bottom or the bottom goes to the top. This is how I think that most junior high math teachers explain it. And I could be wrong. Negative exponents move to the opposite side, meaning when we had 5 to the negative 2, what you can do is you can move this down to the denominator and you can make this as 1 over 5 to the positive 2 in the denominator. And then that negative was just right there, which will give you the same answer as negative 1 over 25. This is kind of just a shorter way to remember the rule that we're going to be following in this class. So that brings us to an example like number 10. 3 over 5 to the negative 2 power. What happens if you have a fraction to the negative 2? If you know, explain it to the person you're sitting next to, please. Tell the person you're sitting next to how to do it. So let's write this. I'm going to put down, I'm going to get to the answer. This is not my final answer, but this means 3 to the negative 2 and 5 to the negative 2. It also means, since I have negative exponents, means I have to do the opposite. 3, instead of 3 groups of 2 in the numerator, it means I'm going to have 3 groups of 2 in the denominator. And instead of having 2 groups of 5 in the denominator, I'm going to move those up and have 2 groups of 5 in the numerator. And then I'm going to simplify that, which is 25 over 9. I hope we did better. How many of you got that correct? Please raise your hand. 1, 2, 3. Ooh. 4, 5. Okay. Here's our final answer, 25 over 9. Let's do another one. Let's go to number 4. So this should be easier because it's earlier in the worksheet. 3 over 6 to the negative 1. The directions will say simplify. Three over 6 to the negative 1. Go ahead and try it. See what you come up with. If you have a question, you can ask the person you're sitting next to. The first thing that I always try to do is I always try to move negative exponents first. So I have a negative exponents here. Right now I'm dividing by 6. One group of 6 in the denominator. What this means, do the opposite. So I'm going to move it up to the numerator. Well, there's already a 3 there. So what this becomes is 3 times 6 to the positive 1 power. And I can simplify that. I know what 6 to the 1 power is. It's 6. One group of 6. Times 3 is 18. My final answer is 18. How many of you got 18? Raise your hand. 1.
That was a small mistake.
Okay. Good job for the one student. Good job, Tony. So I can see, I hope these are small mistakes that you're making. That's kind of scaring me because I thought this would be a little bit easier. Maybe we'll do a little bit more checking for understanding. Let's do one more problem and then we'll do the first half of the worksheet. That's how I feel right now. Let's do number 13. Because everything I've shown you up to now are the small things. And then number 13, it just goes into another level. It looks like this. Negative 6, a to the negative 2, parenthesis, bc, end of parenthesis squared over d negative 4. It's going to look a lot harder. Your order of operations, we wrote it down earlier. The first thing you need to do are parentheses, then exponents. So let's see. Can I do anything in the parentheses? BC, no? Can't do anything there. Can I do anything with exponents and parentheses? BC squared, since it's in a parenthesis, it means you have a BC times a BC. I'm going to write equals here. And I'm going to put BC times BC. There's two groups of BCs times each other, right? I have a negative 6. There. What's the invisible exponent? To the first power. That does not mean we move it. That means it stays the same. I have this a to the negative 2. That needs to go into the opposite place. Instead of it being a to the negative 2, in the numerator, it becomes a to the positive 2 in the denominator. I just draw a little arrow and point it down. Like I'm going to move it down here, and it becomes a squared down there. It's the opposite of. Instead of multiplying, we're dividing. Two groups of them. And then lastly, there's this d to the negative 4 that has to move up. Instead of dividing by d, for those d's times each other, we're going to be multiplying by them. D to the positive 4. And now I can simplify this. I'm going to simplify it the way mathematicians do. They write things in order. They write things in alphabetical order, as a matter of fact. So, numbers first, then letters. Negative 6. Up here in the top, I have b and times a b. How many b's do I have? I have 2 of them. I'm going to write b squared. That's the easiest way to write it. How many c's do I have? So I can write it as c squared. How many d's do I have? 4 of them, and it's all multiply. That's why I just write them next to each other. Over a squared. That's the correct answer. That's how, this is the level that I want all of you at eventually, is this level. Okay? I'm going to pause. There are more notes. We're going to do a part 2 of the notes, just not yet. Okay? I want to give you some time to practice what you just learned.